How to Clone a Mammoth, The Science of De-Extinction by Beth Shapiro. Presentation by Jaria Umutesi and Madeline Peterson. If we really want to bring mammoths back to life, then we're in luck as far as DNA preservation goes. It is in pretty shoddy condition, so hard to piece together, but if we sort through these tiny pieces, finding where they fit along the elephant genome, then we can slowly build a lot of the mammoth genome. Beth Shapiro. Who is Beth Shapiro? She is currently a professor of ecology and evolutionary biology at UC Santa Cruz. She has gotten her bachelor's and master's from the University of Georgia in ecology, and her PhD, or DPhil, from Oxford University in zoology. She's gotten many awards, including the National Geographic Emerging Explorer in 2010 and the Packard Fellow in 2010. In How to Clone a Mammoth, Beth Shapiro, an evolutionary biologist, explains how it is possible to de-extinct an older species that has gone extinct. Using DNA collected from remains, scientists explore the possibilities of bringing back these creatures. Shapiro explains the processes of deciding which species to bring back, how to sequence their genomes, and how these revived species will be watched over in the wild as they are reintroduced to the world. But she also considers the risks and ethical issues there are with being able to de-extinct a species, as well as the ultimate goal of it all. The species in question. The woolly mammoth, Mammothus primigenius, was one of the last mammoth species that went extinct 200,000 years ago. Its closest relative is the Asian elephant, and the mammoth was about the same size as the current African elephants, but is adapted for a cold environment as it did exist during the last ice age. It's covered in fur, has short ears and tails to minimize heat loss and frostbite. Shapiro's main argument is that we can resurrect extinct traits and engineer traits into living organisms. For example, resurrecting traits from a mammoth and engineering those traits into a living organism such as an Asian elephant. Importantly, according to Shapiro, mammoths cannot be cloned. They cannot be cloned because cloning requires a living cell, and there are no living mammoths since they became extinct 200,000 years ago. DNA from living cells make it possible to clone another organism opposed to using a DNA from a bone. DNA from a mammoth bone is damaged and not in great condition, thus making it difficult to make the genome. Steps to cloning a mammoth. According to Shapiro, there are 7 steps that can be taken to be able to clone a mammoth. 1. You must sequence the genome. 2. Put the genes into chromosomes. 3. Place the chromosome into the nucleus. 4. Put the nucleus into the cell so that it can divide into an embryo. 5. Put the embryo into a surrogate. 6. The embryo will need to go into term in the surrogate so that it can be born. 7. When the mammoth is born, then it needs to be in an environment where it can survive and produce more mammoths, as well as be watched over as it is reintroduced into the wild. Here is a visualization of a different way to clone a mammoth. Not cloning, but being able to find frozen sperm and bring it into an egg so that the hybrids will reproduce until there's a nearly pure mammoth lineage. Why the mammoth? There's a possibility to bring back a lost ecosystem with the mammoth, and understanding the genetic makeup of the extinct species could help us understand more about evolution. Plus, humans have a fascination with large animals from the past, and the woolly mammoth has been one of the most iconic animals from the Ice Age, which could mean a ton of money coming towards those who research it if people were to support the project. Authentic science practices. Like mentioned in the first chapter lecture, investigations are ongoing. There are no right answers, and conclusions are not always final and can always be revised. For example, in the book How to Clone a Mammoth, Shapiro explains 3 different plans. When one didn't work, she went on to the next. First, she starts with the idea of cloning a mammoth. But according to her, it is impossible if there is no living organism. So she moved on to her next plan. Her next plan was, if mammoths can't be cloned, then maybe we can sequence the genome from the mammoth bones. Third, which is the last plan, was to engineer a mammoth by using the technique of cut and paste with sperm. Culture affecting science. Shapiro explains how advanced technology has made it easier to be able to clone species. Using technologies such as CRISPR-Cas9, mammoths, like elephants, can be built by editing the genome of an Asian elephant. The Asian elephant is the closest relative to a mammoth, since they diverge from the same ancestor. Even though there's technology such as CRISPR-Cas9, we still don't have the technology needed to clone using DNA, but we have the technology to clone from a living cell. The ethics. Is it morally right to clone a mammoth? Some people say that the extinction of a mammoth is not ethical. Scientists are playing God by trying to bring back an extinct species. Others say mammoths' de-extinction is not ethical because it puts pressure on other animals such as the elephant to produce a mammoth. Also, elephants struggle to reproduce, so those who disagree with de-extinction argue that elephants should be provided with the opportunity to grow its population instead of being involved in mammoth de-extinction. Asian elephants are on the endangered species list as is, so forcing a species that is endangered to help it de-extinct a species that is already gone is too much for them. I personally believe that we shouldn't bring back a species that is extinct. Natural selection has not necessarily weeded it out, but if it has been extinct, then bringing it back could bring it a lot of problems with it because we don't necessarily have the environment for a mammoth to survive in, especially if we want to keep it in areas where people can easily access it. So, bringing back a species that wouldn't easily exist within today's current environment would be a waste of time. Though this could help further our research on evolution and extinction and the genome of animals, as well as cloning, it isn't worth it at this point. Here are references.